Let's talk about solving by graphing today. And what we're doing in this unit is we're learning a lot of different methods on how to solve a quadratic. In our first method, we did the solve by factoring, which is going to be part of our example number 1. But what we're doing when we're solving by factoring, and as we work through today, the solve by graphing, is that we are finding solutions, which are also known as roots or zeros of our function. And what happens is that these solutions are called roots or zeros because when we plug in the value for the variable in the function, the whole function equals 0. But what happens when we graph these functions? Well, we probably kind of already know the answer, but let's start here and practice our solving by factoring. And when we solve by factoring, remember, instead of writing y, we probably want to write 0 equals x squared minus 2x minus 3. And you might want to write that above just to have enough space in here for factoring. Because when we factor, we're going to split the middle in this case. And what we have is we have 1 times negative 3, which is 3. I don't need to worry about the negative. Sorry about that. 1 times 3 is 3. We'll deal with the negative when we get our values back into our factoring column. And the only factors of 3 are 1 and 3. 1 times 3 is 3. Can we ever get 2 from there? And hopefully we can. It's going to be positive 1 and negative 3 when we split the middle. So it's going to be x squared plus 1x minus 3x minus 3. And now we're going to group. So here's our first group, here's our second group, and our GCF in our first group is x. And we're left then with x plus 1. We had 2 x's, we took 1 out. We had 1 x, we took it out. In our next group, here, be careful, because there's that minus sign again. But our greatest common factor is 3. Negative 3x divided by negative 3 is 1x. Negative 3 divided by negative 3 is positive 1. And what we see when we factor here and finish the factoring is that we get x plus 1. And we've got x minus 3. We need to set each of those factors equal to 0. Now I know in general, I try to show all my work. Don't have enough space here. Can you look at x plus 1 and tell me what the root is? It's x equals negative 1. And x minus 3, when we set it equal to 0 and we solve, we get x equals 3. Now, again, I don't have enough space, but all that I did is I took x plus 1 and I set it equal to 0, and I solved. X minus 3, set it equal to 0 and solved. That's what we have done so far. Here comes our second method. We're going to use our graphing calculator. And what I have up here on the graphing calculator screen is I have all of our functions typed in. I have the first one ready to graph on our calculator, just so that you don't get confused. But we're going to be graphing x squared minus 2x minus 3. So the first thing, let's press graph here and see what our picture looks like. And hopefully, as you compare what's on your screen to there, it looks the same. So now that we see this, what we want to know here, or what we want to do, is we want to fill in the table. So we've seen the picture, we know what it's supposed to look like. We're going to go to second and trace. And how about I try this again? Second and graph to get us to our table here. And just a couple of values here that I'm going to copy down off of our table are negative 2, 5. Negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, and 3, 0. I think those are right, and I'm sure you'll correct me if I'm not. But negative 2, 5. and -1, 0, and 0, -3, 1, -4, 2, -3, 3, 0, and it's actually 4, -5, or +5. I couldn't fit that on my table over there. And hopefully your picture is better than mine, but you get the idea here behind this. That's the picture of a quadratic function. And it says, use your graphing calculator, draw the graph of the function, use your table in the calculator to plot as many key points as possible. So I think we've got the key points here. Now we already know what the answer to this problem is because we factored to solve in that first part. What's the relationship between our answers and the graph? And hopefully what you're thinking is, well, my graph crosses the x-axis at -1, which was one of the answers that we found when we factored. And the graph also crosses at that second green point there at 3, another value that we came up with in our factoring part of this problem. In other words, what happens here is that our solutions are the x-intercepts of the graph. I kept the word short, but I want to say it again, especially if you're watching the video. The solutions that we find when we factor are the x-intercepts, where the graph crosses the x-axis. So let's look at example number 2. Here it is again. The x locations on any function where the output, the y-coordinate, is equal to 0 are known, not surprisingly, as the zeros of the function, which just happen to be what we just said here. They're going to be the x-intercepts of the function. Solutions are the x-intercepts. So let's take a moment and let's clear out. Let's go to our y equals. Let's clear out our values in there. I'm not going to clear out mine, but I am going to turn off the first function. And I'm going to turn on the second function. So we're going to be typing in x squared plus 5x plus 3. And if your calculator graphed the first time, it's going to graph the second time. And once we have that typed in, let's hit graph. And really, more specifically here, what we want to do is we want to look at our table. We see what the picture basically looks like. And if your picture isn't looking like that, please tell me so I can help you. So here's our picture. Let's go to our table. And when we go to the table here, I'm just going to scan it in for a moment, but we can graph some points. We don't necessarily have to write them all down, but what we have is we have -5, 3, and -4, -1, and -3, -3, and -2, -3, and -1, -1, and 0, 3. That's going to get us enough there. We're not plotting, we didn't plot all of the key points because one of the values that we're missing is the vertex. But can we figure out roughly where to draw it in our picture? And if you can't tell from the table, just go back and look at your picture on your screen again. And what you see is that the graph drops a little bit below -3 on our graph. So that's where I'm going to draw the vertex on here and try to do a little bit better picture than I did last time. So there roughly is what our picture looks like. We've got some key points on there. We don't have the vertex on there. And I simply use my table. But once we get our picture drawn, on here the first question says, between which x values do the zeros of the function fall? Well, maybe it's better to look at this screen than my actual picture there, which I still think is important to do. But in other words, what are the x-intercepts on here? And because we can't tell exactly what they are, we want to say between. And I'm going to put a blue mark on this. This point right there is an x-intercept, and it looks like it is between -1 and 0. And if we look at the other x-intercept in this problem, I just put a blue mark on it as well. 1, 2, 3, -4, and -5. It looks like it's between -4 and -5. Now our answers are between. And because they're between, can we solve by factoring? No. And if you really think about it, if you look back at the problem, what we see is we're going to have to split the middle, and it's 1 times 3 is 3, and the only factors of 3 are 1 and 3. Will 1 and 3 ever combine to be 5? You can't add or subtract to get 5. So we definitely cannot solve by factoring. And now what we want to do is we want to find the approximate values of the 0. And this is really where the calculator comes into play. What we're going to do, as we go to our calculator screen here, we're going to go to second and trace. And that second trace is going to get us to the calculate on our calculator. The second puts us up, I think it's blue on my calculator, I'm not sure what color it is on yours, but second trace, up above it says CALC for calculate. So second trace. Now as we look at the menu that comes up when we type that in, which function do we want to use? Well, hopefully you're thinking 0. So we're going to go to 0. On here. And what happens is it pulls up a cursor now on our graphing screen. And at the bottom of the screen it says left bound. And for the left bound we're going to use our arrows. And eventually we're going to type in enter. So I'm just writing that down, and I'll give you some time to write this down if you need it in a couple minutes. But since I'm close over here, I'm kind of on the right of the picture, I'm just going to move my cursor so that it's a little bit to the left of where it crosses the x-axis. And my calculator is nice because it's going to put a line in here. I'm going to put it there. My numbers at the bottom of the screen do not need to match your numbers at the bottom of the screen. But you do want that cursor somewhere to the left of where the graph is crossing the x-axis. Press enter. Well, now we need to go to the right bound. So this is going to be the right bound. And again, when we do the right bound, we're going to use our arrows, the right and the left arrows, actually. And eventually, when we get the cursor to where we want it, we'll press enter. But then we're going to scoot over here. Using the right arrows, I'm going to put my cursor there. Again, your numbers at the bottom of the screen do not need to be the same as my numbers at the bottom of the screen. And press enter. And on all of the calculators, to the best of my understanding, there's arrows at the top of there. You might not have the lines. When we press enter, the last time here, that's going to give us the 0 of the function. So I got ahead of myself. I punched it before I wrote the words. But one of our ordered pairs here is negative 0.697, 0. So negative 0.697, 0. But we have 2 of them. And we're going to go through this same process again to figure out where the zeros are. So we pull our calculator screen back up. I'm going to go second, trace, 0. And this time we're going to go using our left arrow, scroll over. Somewhere to the left of where that graph crosses the y-axis. Once we put it where we want it, roughly here, your numbers at the bottom of the screen do not have to be the same as mine. Hit enter. Then we're going to do the right bound. Somewhere to the right of where the graph crosses the x-axis, going to press enter. And in between those 2 arrows is where the graph crosses the x-axis. We're going to hit enter one more time. And we get negative 4.302. Or how about negative 4.303? Zero. And those represent the 2 blue marks on our graph. Negative 4.303 is farther to the left. Negative 0.697 is farther to the right in terms of the blue points. And those are our steps. I'm going to pause the video here for you to copy down the directions if you would like to. Now, I make them, no, I'm going to do it. So let's try this again. I'm not going to graph. But we're going to go to our y equals screen, and actually, before I do, let me look at the big idea here. Graphing a function to find its zeros, its roots, its x-intercept, its solution is really helpful when we can't factor. Factoring by far is the best way to solve a quadratic, but not every quadratic can be solved by factoring. So, for instance, as we take a look at this next one, y equals 2x squared plus 3x minus 5. Let's type it in. So we're going to go to our calculator. We're going to go to y equals. And I'm going to turn this one off. And turn the next one on. We're going to type in 2x squared plus 3x minus 5. And we want the picture. And maybe you're not going to spend the time graphing right now either, because we've got some other things to talk about. But we get it typed in, and let's see the picture. And what we really want to practice is, how do we use our calculator to help us solve? Now that we have a picture graphed here, can we identify the roots? Maybe one of them. And the nice thing for me is that I can put this in here. Can we tell what this blue point is right there? Doesn't it look like it's 1, 0? And I'm putting it here in the wrong place. Well, let's go 1, 0. But do we know what this other one is? Maybe we do. So let's use what we just learned to try to find this other value. And when we do, we're going to go second, trace, which gets us to calculate. Number 2 is 0. And then we're going to use our left arrow to get us over here to the left of that point. And somewhere over here. Your numbers at the bottom of the screen don't have to be the same as mine. Press enter. Then we're going to go to the right. Again, your numbers at the bottom of the screen do not have to be the same as mine. Press enter. And once we've done that, press enter one more time because it's saying guess at the bottom of our screen. And there gives us our other value. Negative 2.50. Can we factor this problem? We can. I think in the interest of time, I'm going to skip the factoring for right now. If you do want to factor, just to tell you, it factors to be 2x plus 5 and x minus 1 equals 0. I know I didn't show my work, but in case you want to go back and actually do the split the middle method to graph, because I think that our time is better spent if we practice on how do we use our calculators to find the roots, to find the solutions, to find the x-intercepts. So as we look at example number 4, I'm going to go back here, and again I will turn off this screen and turn on the next one so that we can graph. We're typing in negative. Remember that the negative button is at the bottom of your calculator screen. It's different from the minus button, which is over on the right hand side of your screen. Negative x squared plus 6x minus 2. And when we hit graph, there's our picture. So nice that we have at least a little bit of a difference, and I'm not going to take the time to draw the picture on our grid over here. What I want to practice more so is, can we find the roots, which are between 1, 2, 3, 4, 5, 6, between 5 and 6, where that blue mark is roughly, and between 0 and 1. I'm trying to move that point so it's on there and it doesn't want to move. Alright, but hopefully you get the idea. Sorry, there, moved a little. There we go. So based on the nature of the roots, we need to figure out if it's factorable or not, but we got to find the roots first. So this is where we're going to use second trace. That gets us to the calculate button. Second trace. Number 2, the 0. And I'm in a good spot. That value right there where it happened to show up, and I don't know if it showed up on your screen or not like that, but it's to the left of our first blue point. So I'm going to press enter. I'm not even going to move it. But then let's use our arrow button. And let's go a little bit to the right of that. Press enter. So somewhere in between these two arrows up here, we can only see one of the dotted lines. I'm going to press enter one more time. And it looks like we get 0.3540. By the way, Inspire people, I think that I would like you to write Inspire on your quiz tomorrow, because I don't think that you're going to get as many decimal points as me. So it's just a reminder. But we just found, again, the blue point to the left. Let's look at our blue point to the right. Second trace, which gets us up to calculate. Number 2, the 0. And then we're going to use our arrow buttons. And it's going to take me a couple minutes, so you can go faster than me. Somewhere over here. Your numbers don't have to be the same as mine at the bottom of the screen. Press enter. And And then we're going to go a little bit to the right. Here. So our values are in between there. And then we're going to press enter one more time. And we get 0.5646 when we round. 5.646. 0. Can we factor this one? No. In general, if we get a big long decimal like that for our answer, and I know the Inspires, it doesn't show up as much, but if you get a big long decimal like that, in general, you can't factor.